problem today is tasks and deadlines. So what's going on here? We have n tasks to do. Each task has some time that it takes and a deadline. And we get to pick the order that we're going to do them. And when we finish a task, we get a reward of the deadline minus the finishing time. Right, so like starting at 0, counting up by the duration, and we have to do all the tasks, even if we're past the deadline, in which case we get a negative reward. So the question is, how can we maximize the reward that we get for doing all the tasks if we act optimally, by which it means we choose the task in the right order. Right, so the input is that there's 200,000 tasks, and each one has a duration and a deadline. So for example, here we can get 2. If we do this task, we get 7. And then if we do this task, we get -1, because we've taken 11 time, right? 5 plus 6. And then if we do this task, we get -4, because we've taken 5 plus 6 plus 8 is 19 time, minus 15. 15 minus 19 is -4. So 7 minus 1 and -4 gives us 2 in total. So how do we do this? So the key point, right, so we want the sum over tasks of d minus f. And the key point is that we can separate out this sum, right? So this is equal to the sum over d, sorry, the sum over tasks of d minus the sum over tasks of f. And this doesn't depend on the order that we choose at all, right? This is just some fixed from the thing from the input. So this is always going to be the same. So the only thing we have any control over is this. So we want to minimize the sum of the finishing times, right, to maximize this, which is the total reward. So how do we minimize the sum of the finishing times? So the point is that we want to do it greedily with the shortest task first. So why is that? Well, so these are like partial sums of the durations, right? So like f0 is just the duration 0, but f1, well, you have to do task 0 and task 1. Right, like these f's that we're going to subtract are partial sums of durations. So we want to minimize the sum of partial sums. And so the key observation is that d0 is going to appear in this sum n times, right? Just look at it by columns. Because like another way to think about it is all n of the tasks are waiting on the first task. And then n-1 tasks are waiting on the second task. And n-2 tasks are waiting on the third task, and so on. So to minimize the sum of the f0s, we should sort the d's, right? We should process them in sorted order. Because sum of f equals n times d0 plus n-1 times d1. And so the way to minimize the sum is, just to pick d0 as the smallest one. So let's do that. So we read in n, and then we read in the duration and the deadline for each task. So deadline, we can just add to the answer, right? What we were saying, like the first term in the answer is just the sum of the deadlines. We don't need to make any choices about that. And then the durations, we're going to stick in an array because we want to sort them, and then process them from low to high. So f is going to be the partial sum. And we subtract those partial sums from the answer. So we do the usual includes, and we also need algorithm for sort. So yeah, this implements the strategy that we talked about. Right, we read the durations in, we read the deadlines in. The deadlines just get added directly to the answer. We split the durations from low to high. F is going to be the partial sums of iterations, right? So we add each new iteration to F as we do that task, and then we subtract off the finishing time for that task. And at the end, we just cannot do this. I should probably declare my array. And we get 2. That's good. Okay, and submit. Cool. So this worked. So yeah, break down the sum into 2 parts. Realize that this part is independent of our choices, so we only care about this part. And then sort of do this sum by column thing, or just expand out what this means in terms of the d0s, and then it's sort of obvious that you want to pick the smallest, do the smallest thing first. And the intuition, another intuition, beyond this algebraic one, is that there's n tasks sort of waiting behind the first task, right? So the first task sort of delay counts like n times because everyone has to wait for it. So you want that to be the smallest guy, and so on. And so we just implement that, right? Now that we know what to do, we just sort it, and like it's almost a simulation problem, right? Once we pick the order, we can just do what they tell us to do to compute the score.